Okay, I'm 52 weeks of Swift here, and there's not many more sections of the language guide to go through. There's only four more, and I would say I have had mixed results in understanding this just without doing any pre-reading, which I think is probably other people's experience too. There's some topics that they're pretty dense and not topics I typically would dive into, like this week's. But at the end of this, then I'm going to start building actual solutions with Swift, which I think will be a lot more exciting than some of the stuff I've been covering. But for now, I'm going to keep going here, and I'm going to share my screen and share a playground. So let's go through here and go to a playground, and I will dive into this thing. So the thing that's the topic this week is the concept of an opaque type. And so with an opaque type, it definitely is something that feels more like a framework developer. And so the idea is that it hides type information between a module and code so that people don't have to expose it. And it says in particular that the problem that OpaqueType solve is, and this is the example they give, is that you're writing a module that draws ASCII art, and the shape is draw function, and it returns a string representation of the shape, and you can use that as a requirement for the shape protocol. And so you could use generics to do something like that. So they have this example here that is able to be run, but the generics would like that would flip the shape, and all those kinds of things would expose some of the underlying infrastructure. And so the flipped result would expose the exact generic types that were used. So I guess if you wanted to hide some of the implementation of what it is you're building, that's the thought process here, which again is a little bit unusual because I think that there's a certain kind of developer that has to deal with those problems. That has absolutely not been my career. But this is a topic that I'll go through anyway. And it says there's another approach that we can do here. And if we just go through and we print this out, we can see what it is. And I guess the idea is that exposing detailed information about the creation of a shape allows types that aren't meant to be part of the public interface. So I guess from a security standpoint, like you're building some kind of security-based Swift SDK for, I don't know, a banking system. Okay, this could be something where you really need to be careful, because if you expose the inner workings of your SDK, it could really cause some issues. And so the opaque type is like a reverse of a generic type. So a generic type lets the code calls a function. Basically, it lets you decide, what type is appropriate for the given task at hand without doing it up front. But the opaque type is, I guess, the opposite of that. And so the roles are reversed for a function with an opaque return type. An opaque type lets the function implementation pick the type for the values it returns in a way that's abstracted away from the code that calls the function. So let's see if I can understand this. This is an interesting concept. So I'm going to paste this in here. So we got a struct, which is a square here inside of, we probably need the other stuff that I did earlier. So let's do all this. So we got struct square. We have a function here. And then we have another function called make trapezoid, flipped shape, let trapezoid. Okay, I see this, but where's the opaque type? So it says the make trapezoid function declares its return type as some shape. So make trapezoid return type, some shape. Okay. As a result, the function returns a value of some given type that conforms to the shape protocol without specifying a particular concrete type. Writing make trapezoid this way lets it expressed the fundamental aspects of the public interface without making the specific types the shape is made from a part of the public interface. This implementation uses two triangles and a square, but the function could be rewritten to draw the trapezoid in a variety of other ways. So it is like the opposite of a generic type. Well, interesting. And so if we go through and we run this, I guess this is really, again, the reason to do this would be if you wanted to go in and build, I'm assuming from a security perspective, a very secure API. And I guess one final thing that they bring up is that there's also a comparison between protocol types, and an opaque type does look a little bit like a protocol type as a return of the type of a function, but they're a little bit different as well. So interesting. I don't know if I would ever write code that does this, but it's interesting to look at it. All right, so next week we're getting to the finish line is automatic reference counting. Now I have used this, and I do like it, and that'll be, I think, a kind of a fun topic to play around with next week. All right, see everybody next week.